My name's Ron Verhappen. Was the MEDLI2 Mission Operations Manager, which for MEDLI, we end up being really a 20-minute mission because we're just on during the entry into Mars on the Mars 2020 rover mission. So what we did for MEDLI2, it's the Mars Entry Descent Landing Instrument 2, because we flew on the first Mars rover. What we do at Langley, we are interested in how the atmosphere, really what the composition of the atmosphere is and how thick it is and going into Mars. So our instrument consists of a suite of pressure transducers, thermocouples on the heat shield, and then also on the back shell of the spacecraft we have a radiometer, a heat flux sensor, and also a pressure sensor and some thermocouples. So we build the thermocouples and the radiometers in conjunction with Ames Research Center out in California, and then the rest of the things are developed at Langley. The main box that we have is the SSE, which is Sensor Support Electronics, and that's pretty much our brains. That's where we acquire the data, do some averaging, make sure everything's good, and then send that on to the rover. It records it and then sends it back to Earth. That box system was built at Langley, and so it was tested at Langley. Went through thermal vac, vibration, all kinds of EMI testing, all kinds of testing there. And then once we got the engineering model and the flight models together, we kept on working on the flight model. We took the engineering model once it was close enough to what flight was like, and we integrated that in the test bench at JPL, and it stayed there for all their scenario testing, all their rehearsals, all their planning, all their software development. So we were part of that whole system. And then as the flight units became ready, we built two, a primary and a spare. We sent the spare unit out to JPL, and I went into their clean room there with the rover, and we electrically integrated it with the rover for their system level testing. And so we get all that data back to Langley, and then do the analysis, make sure we're talking and everything's right. We took the flight unit out to Lockheed Martin in Colorado, and we integrated that onto the heat shield, and we were there for testing it. So we have a large harness, and it's connected all the instruments on both the heat shield on the back shell, and then using my computer that I'm on right now, we connected that to our SSE, and then we made sure that all the data was coming back as expected. Pressure transducers, they're calibrated to work in the Mars atmosphere, so not ours. So those were on the rails, but all the temperature sensors and the radiometers, we could actually tell when the air conditioning was coming on and off in the clean room with that instrument. And the thermocouples, we would take a hot lamp and put it near it on the heat shield on the thermal protection system, and verify that we were measuring what we were expecting. So the thermocouples are in a plug of the same material that the heat shield's made out of, and there's one really close to the surface, and then several more that are deeper in, so you can tell how hot the whole thermal protection system's getting as we enter Mars atmosphere. So that's all the engineering work, and that was a lot of fun. And then we get to the launch pad, and we do testing with the rover. We turn on the pad, and we can see how warm it is and how cold it is in Florida. It's kind of interesting. And then launch days, it's awesome because you're something that you've worked on for 4 or 5 years that you hand carried around the country, that sat in your living room, that your kids saw, your wife saw, is carried it through the airport with TSA letter saying it can't be x-rayed, so everybody looks at you a little funny, but it all works out, and there it goes off to Mars. And launched in July, and we landed on February 18th, so it was a 8-month or so flight. And so what we did during that flight, because we turned on twice to make sure everything works. So the rover's a fully redundant system, so it has a primary side and a redundant side. So not knowing at that point which side we'd be on when we entered the Mars atmosphere to do our science measurements. So we turned on in October on the A side and took about 3 hours of data, and then we turned on the redundant side a month later and made sure everything there was good. So everything checked out. We survived launch, which is always a critical thing, fingers crossed. And all our detectors, all our thermocouples survived. There's always a chance of a wire breaking here or there, and the pressure sensors, they all nicely read 0 because we're in vacuum of space. And then on entry day, being COVID world, we weren't able to go to JPL with the team, and they had a very limited team there. We had our team of about 6 or 8 of us at Langley, and in the control room there, and we got online, we gave the go-ahead to turn on the instrument, and we started getting telemetry down at a very low rate. And we saw the instrument was warming up nicely and getting thermally stable, so we were ready for entry. And then as entry starts, the rover is generating a lot of data, so they have a lot of that is really throttled down. And as you go with the plasma, there's a blackout, but there's some X-band data that comes back at a very low rate, and it's called tones, and the tones are just telling you things that are going on. It tells you about separation of the heat shield, parachute deploy, things like that. But we also had 2 tones for MEDLI, and one was just say, hey, we're starting to warm up, and our sensors are seeing heat, and also that we're seeing pressures, and those tones tripped, and they were announced, they tripped. They expected to trip. We were excited about it. We could see the telemetry, and it was announced by the ops team at JPL. So it was always exciting to hear your instrument. And then as the parachute deployed, you see, you hear people cheering because that was their part. And, we're getting data, but when the heat shield separates, our mission is over. So now we just wait for our data. And this was a Thursday. We got our data on Sunday. And now we're busy analyzing it because we're trying to get the timing right and get it all perfect and get the calibrations correct, especially with the pressure transducers, because, they feel a shock of launch. So the zeros kind of change. So we've been adjusting those and thermally compensating for all the sensors we have inside there, like 10 meters of wire just to go to one sensor. We have thermocouples inside there to see what the gradient is on the cable and the harnessing, and correlating all that data. So it's all coming together, and we have our first TIM with JPL in May to talk about this data and everything that's going on. So it's really exciting, now knowing that something that you worked on is on Mars, and we've seen pictures of the heat shield laying on the surface. So it's really exciting. It's a lot of fun, very rewarding as an engineer to work on something and see it all the way through fruition. So they call me the mission ops manager, but I was involved a lot with the AINT, which is the assembly integration and test, both at Langley, and then delivering the instrument and the SSE to both JPL and Lockheed Martin, and then verifying that it worked at Kennedy when we were all together with the rover for the first time, and the heat shield and the back shell. So it was very, very interesting. A lot of engineering data to analyze and questions to answer. So really good, fun mission.